is there anything that we can do next? Somebody help here. What else can we do next? Calvin, what else can we do next here? Yeah, you can simplify, okay. Maybe let's start canceling first, then we'll simplify it. What cancels, Calvin?
The negative 2a squared positive a squared.
Okay, yeah. Anything else?
Negative 5a and 5a.
Yeah. Anything else? Now, thank you, Calvin, and I'll neaten that up in a sec. So I'm going to embarrass someone in class, I won't mention his or her name, okay, but when they were doing one of those awful questions, okay, they didn't have everything cancel out. You have to have anything that does not have an H cancel out, okay, so in this case, it's anything on the right-hand side, those last three things, and like the minus f of a has to cancel. Okay, so please be aware of that. If you get something messy, and I'll probably give you one messy thing tomorrow so everyone doesn't get 100%, okay, for that. Make sure that when you do it, like just, you know what I mean, the right-hand side cancels. That's the idea. All right. Okay. Peter, how does this? What does the numerator change into now? All right, Dexter, why am I happy? H is all cancels. So M is going to be negative 4a minus 2h plus 9. That's my equation. All right. Next step is what?
You substitute a for 1.
Yeah.
X for 0.
All right, so it's going to be negative 4 plus 5. Did anyone get the same answers on?
Yep.
Weird. Sorry.
No.
I got one.
I got one.
I got one.
Do I know why I'm thinking this is weird? Because what was the arbitrary change?
Negative 1.
And the instantaneous was positive 1?
I would like.
It must just like, it must do something crazy. Like the graph would have to go something like this, right? So this is 1, this is 2. It must do something like that, because there's a positive slope. That would be your negative slope over there. It must do something like that. Did everyone get those same two answers?
Yeah.
Negative 1 and 1? Okay, well that's what happens time. But you can see why I'm freaked out by this stuff. Like it's things that are counterintuitive for sure. Robin, you're with us? Be with us. Okay. Let's do some graphs next, okay? Here comes graphing. Okay, so I'm going to graph this one as neat as I can. Sometimes this will be on your test, and it was on your assignment, and people were scared being afraid of that. Now, the reason it didn't look exactly like that, what did I make you do on your assignment? What was the difference? Foxton?
You just said, like, this is the order.
Yes, that's a different type of question. I did do that one too. But what else did you for this one? Go ahead. Yes? But there are questions like this, so what do I do? Yeah. I had to factor, right? So I gave it to you in like standard form. If there's one with a quartic, you need to factor it all out. There's another one with like 2 cubic times a quadratic, right, that you have to factor all out. Now, Owen, I'm going to embarrass you, I hope you don't mind. Owen saw this and he tried to foil everything out. Luckily, I caught him in time before he did. Okay, what can you use this? Why is this the version we want? What will this give us right away? Go ahead. This will give us the roots, right? And that's what we need for this, okay? If you foil this out, that's fine. But remember to graph, you're always going to need the roots here. Okay? Yeah, go ahead.
On the test, we have to graph something like that.
Yeah.
So do you want us to find the likely?
No. All I'll say for this, I will leave it just like the assignment. I'll say use end behavior and roots. That's all I'll say to graph this, okay? If I want anything else, I'll let you know. Somebody else found the y-intercept, I can't remember who that was, I helped so many people today, and they got a y-intercept of like negative 1500 or something like that, and they said, is this right? And I said, yeah, probably. Okay, right, these numbers get very, very big for like quartic and, you know, quintic equations, they get really, really big in a hurry, okay, so don't worry about that. Okay, I'm gonna hit pause in the video, I want you guys to graph that. Okay, then I'll take it up in about 2 or 3 minutes here. This should be one of the fast ones tomorrow.
Order 2 roots of 4, order 3 roots of 4.
Good. Okay. Owen, will this be an even or odd function? How do you know? Okay, why?
Because the idea is exponents.
Yeah. So we go 1 for 2x, 2x plus 3 is 5, plus 2 is 7, okay? So this is going to be a negative odd function. Okay, Albert, what is the end behavior of something that is negative and odd?
From quadrant 4 to quadrant 3. 2.
Quadrant 4 to quadrant 2? Yes. I got a line here. So what that says is, as x goes to infinity, y goes to negative infinity. As x goes to negative infinity, y goes to infinity. Here's my rough sketch. Just a sketch. So I'm going to draw this here. There's 1, there's 2, there's 3, there's 4. There's negative 1, there's negative 2. Okay, can somebody please tell me, Robin, how I graph this? With points on my roots. So there's a negative 2, there's a 0, there's a 3, there's 4, good. All right, what do we do next, please?
You have the end behaviors.
Okay.
As x goes to negative 51.
Now, those I'm going to draw lightly in pencil, okay, right? Because if there's like a double root at the end, it's going to look sort of U-ish, right? So you want to sort of make it look like a real graph. Okay, so I have an order 3 root at negative 2. Oh, yeah. Tristan, how do you deal with an order 3 root?
Does it go through like a curve?
Yeah, it does go through like a curve. So what I'm going to do is erase that and make it sort of look sort of like this. Okay, so it sort of looks like a cubic function, looking like that. Okay, 0 is an order 1 root. Fox, if I have an order 1 root, how do you draw an order 1 root?
Normal way?
Normal way. I hope you mean straight through, okay? So we're going to go something straight through, sort of like this. Okay? 3 is an order 1 root. How do you do that? Straight through? And Atlanta Waller, 4 is a order 2 root. How do you do that? Yeah. So treat it just like a x squared with like a vertex, right? So it's going to look sort of just like this. That's what that one should sort of look like. Now, can we find the local max, local min? Yes. Can we do it today? Definitely not. Okay. This will not just be the midpoint. Okay, for that. This one will be because it will single, but we'll get to that in later courses. Okay, but mainly calculus. Okay. Good. Sort of okay. Yeah, go ahead.
So like when we draw graphs, you want us to mark the y one too, but like we don't know it. So we just need
Yeah, you don't need a scale. You don't need to put a scale on that, right? Like you can put the numbers on if you want to, but I'm not going to say I'm going to leave no scale because if you plug in f of negative 1, well, I don't want to do it with my hand. It's going to be too big of a number. It'll be like a huge negative, like negative 1,000 or something like that, right? So you don't need to put a scale on for this. Right? Yeah. Because this, yeah, exactly. Yeah, that's fine. Because like I said, the only thing I'm marking you on is your roots and then behavior, that's all it is. Okay, we're feeling okay with that? Yeah, cool. You have to write one of these things, either this or this. I prefer this, strongly, okay, strongly, strongly, because as we get towards topics, we're going to talk about limits and about functions going towards infinity and stuff like that. We'll need this later in this course, okay? I was strong for that, but either one is still correct. I will give you a mark for this, I'll give you a mark for this, and I'll give you a mark for this, for this chapter. Okay, ready? Example 3? Yes, here we go, example 3. Find the equation. Okay, this one's going to be an F2. You can do it. Okay, all these questions on the board, I'm